In today's episode, I will show you how to make an Hbridge simulation in Proteus, how to write a program to control the direction of a DC motor using relays, and then how to practically make an Hbridge module. But before we start working on the simulation, first let's understand what is an Hbridge and how it works. Let's get started. An Hbridge is an electronic circuit that switches the polarity of a voltage applied to a load. These circuits are often used in robotics and other applications to allow DC motors to run forward or backwards. The term Hbridge is derived from the typical graphical representation of such a circuit. An Hbridge is built with 4 switches. These switches can be MOSFETs, transistors or relays. When the switches S1 and S4 are closed, and S2 and S4 are open, a positive voltage will be applied across the motor by opening S1 and S4 switches and closing S2 and S3 switches. This voltage is reversed, allowing a reverse operation of the motor. The switches S1 and S2 should never be closed at the same time, as this would cause a short circuit on the input voltage source. Most commonly used Hbridge modules consist of L293D and L298N ICs. These modules are also known as motor drivers and are used in robotics for motor direction controlling and speed controlling. I will provide links in the description if you want to purchase a ready-made module. Now open Proteus and click on the Pick from Libraries button and search for the Arduino Uno. Double click to add this to the list. Now search for 2N2222 NPN transistor. Double click to add. Now search for the relay. And click OK. Now search for a resistor and double click. Now first of all add Arduino. Right click and rotate. Now click on the relay. Now again click on the Pick from Libraries button and search for a DC motor. Select a simple DC motor model, double click to add. Now select a motor and click. Now right click and rotate clockwise. Now connect one terminal of the motor with the common of one relay and the other one with the common of another relay. Now click on the 2N2222 NPN transistor. Place one over here and another one over here. Connect the relay coil with the collector of the 2N2222 transistor. Connect both the emitters. Now click on the terminals, select ground and connect. So the emitter of both the 2N2222 transistors will be connected with the ground. Now again click on the component mode and this time select a resistor and connect this with the base of the transistor. These are 10K resistors. Now connect this resistor with pin 7 of the Arduino and another with pin 8 of the Arduino. Now again click on the terminals, select power, place one over here, another one over here, one here and one over here. Connect this with the coil. Now double click and write plus 12 volt. Same for here, select. Also for this one, and same for this. Connect this with the normally open of the relay and connect this one with the normally open of the relay. Okay, one more thing, we have to add the grounds, so connect the normally close with the ground. So now let me explain the connections. So as you can see, the motor is connected with the common contacts of the relays. So the motor one wire is connected with this relay, and the motor second wire is connected with the common of this relay. And over here you can see a 12-volt supply is connected with one side of the relay coil, and the other side of the relay coil is connected with the collector of the 2N NPN transistor, while the emitter is connected with the ground, and with the base a 10K resistor is connected, and then it is connected with pin 7 of the Arduino. So when we turn on this transistor, it will turn on this relay. So when this relay is turned on, this contact will connect with the 12-volt. So the 12-volt is coming from here, and it is already connected with the ground. So the 12-volt is coming from here and the ground is coming from here, so the motor will be rotating in another one direction. And when we turn on this transistor and turn off this transistor, then this relay will turn on, so the 12-volt will be coming from here, and the ground will be then coming from here, so the motor will be rotating in another direction. So that's how an Hbridge is working. So when the current flows from here to here, and when it flows from here to here, it makes an H. So that's why it's called an Hbridge. This is a very basic program written for controlling the direction of a DC motor. The purpose of this program is to rotate the motor in one direction, then stops the motor for 1 second, then rotate the motor in another direction, then again stops the motor for 1 second, and then this cycle is repeated again and again. As we are using two relays for controlling the motor direction, so we start by defining two pins for the relays. Integer relay 1 equals 7. Relay number 1 is connected with pin 7 of the Arduino. Integer relay 2 equals 8. Relay 2 is connected with pin 8 of the Arduino. Every Arduino and Mega program has at least two functions, which are white setup function and white loop function. White setup runs only one time when the Arduino or Mega board is powered up. White means that this function is not returning any value, and the empty parentheses means that this function is not taking any arguments as the input. Pin mode is a function and takes two arguments as the input, which are the pin number or pin name and the status, which can be input or output, as we are using relay to control the DC motor. So over here the relay is an output device, so that's why set it as output. Pin mode relay 1 output, pin mode relay 2 output. Digital write relay 1 low, digital write relay 2 low. Digital write is a function and is used to turn on or turn off any pin of the Arduino Uno or Mega. So the purpose of these two instructions is to keep both the relays in off state when the Arduino or Mega board is powered up. Then starts a while loop function. This function runs infinite times. To rotate the motor in one direction, we turn on the relay 1 while relay 2 remains in off state. Digital write relay 1 high, digital write relay 2 low. Then there is a delay of 1000 milliseconds, which is equal to 1 second. Then we turn off the motor. For this we use the instructions digital write relay 1 low and digital write relay 2 low. Again a delay of 1 second. Then relay 1 remains in off state and the relay 2 is turned on. Now the motor will rotate in another direction and so on. We are done with the programming. Now let's generate the hex file needed for the simulation. For this, first of all click on the file menu. Then select the preferences and check both the compilation and upload boxes. Now click on the compile button and wait for a while. Now select the hex file link and press Ctrl C on the keyboard to copy. Now double click on the Arduino board and paste the link in the program file text box and then click OK. Now run the simulation by clicking on the play button. As you can see, the motor is rotating in one direction, then stops, and then rotating in another direction, and then again stops, and so on. This is the PCB design of the relay based Hbridge module designed in CADSoft Eagle. If you want to learn how to make PCB designs using CADSoft Eagle, then watch my tutorial. Also watch a tutorial on PCB design, transferring and etching. The PCB design is as per the simulation circuit is explained. Over here we connect the 12 volt and ground wires coming from the external power supply. Over here a DC motor is connected. As you can see, the motor will be connected with the common pins of the relays. The normally closed and normally open contacts of the relays are connected with the external power supply. These are two N2222 NPN transistors and two 10K resistors. Now let's use the same components, two N2222 NPN transistors, 10K resistors and relays to make an Hbridge module. So this is the Hbridge. These are two relays and two resistors, 10K resistors, and now we will do the soldering. So first of all we will solder the 10K resistors, and then after that the two relays. So now these are two transistors. Okay, now we are applying some solder to the wires to increase the current rating of the copper wires. So now we are connecting the yellow wire and the red wire with which we can connect a motor. And now these are supply wires. The red is a 12 volt wire and the blue is the ground wire. And now these two wires are connected with the 10K resistors, later which will be connected with pin 7 and 8 of the Arduino or 80 mega 3 to 8 microcontroller. So now let's check the short circuit and the continuity. So